This tutorial will explain how to do the rule of arrow introduction in the ProofLab. So you can see and specifically how to use version 1 of the rule of arrow introduction in the ProofLab. So you see that we have this, let's zoom in a little. Let's make this a little bigger. Okay, so our conclusion is this big, long conditional. And we don't have anything to work with. We don't have any way to get the consequent of the conditional S arrow R and T without making an assumption. We also don't have a way to get the consequent of the inner conditional R and T without making an assumption. So we're going to need to make an assumption. And the way we get an assumption into the proof in the ProofLab is we click on the conditional that we want to derive using arrow in, and then we click on the rule of arrow in. We can see in the rule preview what it's going to give us. It's going to put A, which is the antecedent of the conditional, as an assumption, and then it's going to direct us to the consequent of the conditional, in this case S arrow R and T, as a goal. And then we click apply. This rule can only be applied backwards. When we need to make an assumption, you have to work backwards. There's just no way around it. Okay, so now our goal is to create the conditional S arrow R and T. Again, there's no way to get R and T directly, so we're going to have to do another arrow in proof inside this current arrow in proof. So what we do is we click on the conditional S arrow R and T, and again click on the rule of arrow introduction, and you see how it makes this nice nested proof. So that's really helpful, and that's how you want your proofs to look when you're doing them by hand. Okay, so now our goal is to get from S to R and T. Well, we see that using S, we can get R, which will put us part of the way there by arrow elimination. So that's helpful. And we want to get this by and introduction, we know, so we can work that backwards. And we've already got the R, so we're good to go. Well, now what we need to get is a T. So T is buried way back in this conditional. So we're going to have to dig for it. So the first thing we need to do is get a D. Well, where are we going to get a D from? We're going to get it from line 3. So we can use line 3 and line 4. So you notice that it goes here, and that's going to be fine. In another tutorial, I'll talk about how if you do something like this and you don't want the D to go in this box, let's say you wanted it to go in the inner box, I'll show you how that works in a different tutorial. Okay, so then we're going to use this D to start digging away at this first conditional. Okay, and now we want the T to go inside the box, but since the S that we're using to get the T is inside the box, it's just going to end up there. It can't go anywhere else because it has to go below the S. And the proof is complete.